Okay, good morning. So today's the second lesson talking all about the network stack, TCP, the transfer control protocol and internet protocol stack. We want to consolidate what we learned last time. Remember, our connection to the internet went down for most of the lesson last time, so it's a good example of what happens when one layer breaks. The rest of the layers continue to work, and you can just focus on fixing the problem on that individual layer. So it was a good example of both decomposition, breaking a complex thing down into smaller parts, and abstraction, because you can only have to worry about one aspect of the stack at once. Today we're focusing on the protocols. Remember, a protocol is just a set of rules. It's absolutely necessary to have a set of rules, because if everyone had a different set of rules about which way to walk down the corridor, then you'd collide into each other. If everyone had a different set of rules about when lessons started and finished, then people would never turn up at the right time. Certain rules are essential, and we need those rules in networking because the computer sending binary data needs to agree on what that data means with the person receiving that information. So the set of rules, the protocols, enable communication. Okay, so we've just described what the stack is. Can you remember how it works? Well, we've got ATIL. ATIL. You should hopefully remember which order these are all in. Okay, so we've talked through in class what happens at this layer. Application would be requesting data, sending data, receiving data. Transport layer, splitting your request into packets, sending your data as packets, receiving your packets and reassembling them back into the data. Internet layer is all about source and destination IP address and routing to go through in different directions. And link layer is all about sending or receiving that data at the right timing, so that each bit gets translated into a burst of radio energy or a light pulse or just electricity on and off. So we need to talk about the protocols, the specific protocols, the separate protocols that happen at each layer. So we need to put them in order. Just remember ATIL from top to bottom. And these are some that we've got. So straight away, if you've got your Word document open, you can be popping these into the right layers. So a good example of what happens at the application layer are all of these. HTTP, Hypertext Transfer Protocol, or Secure. That's where your web browser says, please can I have this picture, or please can I have this web page, or please can I have this JavaScript file, or please can I have this video stream, and please can I have it encrypted so that anyone else seeing the packets can't understand them other than you and me. FTP, File Transfer Protocol. Please can I download this file, or please can I upload this file. Simple Mail Transfer Protocol, as in sending an email from your computer to another computer. POP3, Post Office Protocol, third version. It's for downloading email messages from a server to store them on your computer. When you download them from the remote server, they don't stay there anymore. They're only on your computer now. An IMAP, can't remember what it stands for. You can Google it, I'll give you a class charts positive. I think it's Internet Messaging something or other protocol. I can't remember what the A stands for. Great, look at that, Internet Message Access Protocol. This one is again for receiving email, just like the Post Office Protocol, but this one keeps the email on the remote web server so that you can access it again at a later date, possibly from another device. So these are all application layer. Why? Because the user is involved in initiating these. They're all to do with an application that runs on a computer or a server that is hosting and delivering access to these kind of things. If you move down the stack, we're on to the transfer layer protocol. And here there are two main protocols, TCP and UDP, Transfer Control Protocol or User Datagram Protocol. Transfer control protocol is reliable, as in if a packet gets lost, then it's going to automatically get resent until it's confirmed. Transfer control protocol just breaks down large files or large payloads into smaller packets and it reorders them. UDP does exactly the same. It breaks things down into packets, but if one packet gets lost, you don't really care. So for live streaming and for low latency gaming, UDP is what you want. But for downloading files in a reliable, consistent way, TCP is what you want. Internet layer protocols. So the only one that you need to know about here is IP. There are other ones, but the one that is used for the internet, surprisingly, is the Internet Protocol. How does it work? Well, you have an IP address, usually an IPv4 address, but you can have an IPv6 address. 32 bits to say where the message is from, 32 bits to say where the message is to. So 32 bits is 4 bytes, something like 127.0.0.1 is always the IP address for yourself. So if you ever send a message to yourself, that's your IP address. Link layer, so we've got Ethernet or Wi-Fi, or it could be Bluetooth, or it could be fiber optic. Fiber optic via Ethernet, or however you want. All sorts of different ones. This is all about the timing, how long each bit lasts for. It's about the physical medium. Is it a twisted pair of copper cables? Is it a 2.4 gigahertz radio signal or a 5 gigahertz radio signal? How do you interpret those and turn them into bits and bytes? So, you've listed them. Tell me what the acronyms are. Tell me what they stand for. If you can't remember from what I've said, then you've got the internet, which uses all of these layers. If you request for application layer protocol, you'll be typing something into Google Chrome. Google Chrome will initiate a request using HTTPS. Google Chrome will send a message to the operating system. The operating system will break down your request into TCP packets. The operating system will also add in the headers and footers at the internet layer to say your personal IP address is the sender. The recipient is going to be Google, so it will look up the Google IP address using DNS. And then your network card will send that request over Ethernet to the router in school. The router will operate at the internet layer to look at the IP addresses, and it will forward those packets on across the fiber optic cable through school, and then it will get routed across the internet. And eventually Google will respond, the application layer, the web server, sending the packets, routing them across the internet, timing them specifically at the link layer, and eventually you'll get the stuff back in your Google Chrome. So when you move on to activity 2, meaning is just what the letters mean. Purpose, what it does. So hypertext transfer protocol in meaning. Purpose, to request and receive resources over the internet. Example, downloading a file from the VLE. So I'd like you to fill out the whole table, and then you can choose one of these to research in more depth and turn that into a PowerPoint presentation. That presentation is going to be presented to the whole class. Feel free to use your revision guides. Feel free to use the internet. Quickly fill out the table, choose one, and I'll ask you to present it to the class. Okay, so when you've finished, you need to make sure that your Word document is uploaded to Half Term 7 Networks 2. If you've done the extension, which is to choose one of the protocols and create a PowerPoint doing a little bit more research into exactly how that works, when it was introduced, are there any alternatives to it, strengths, weaknesses, vulnerabilities, all that kind of stuff, just take a screenshot of the best slide, put it at the bottom of your Word document, save the Word document and upload, please, to Half Term 7 Networks 2.